This is part 7 of carbohydrates, and in this part we will see ring structure of D-glucose. The open chain structure of glucose proposed by Bayer failed to explain the most properties of glucose, as we have seen in previous lectures. To explain the phenomena of mutarotation, it was realized that alpha D plus glucose and beta D plus glucose were in the cyclic hemiacetal form of glucose, which are interconvertible via open chain form. The constant value of specific rotation, that is 52 plus 7 degree, represents the equilibrium between these two forms. To account for experimental observations, cyclic structure was proposed for D-glucose, in which the aldehyde group is not free. Rather, it forms hemiacetal with hydroxy group at C5, that is fifth carbon. So 1, 2, 3, 4, and 5. This is the fifth carbon, and with, okay, let us see here, 1, 2, 3, 4, 5. This is the fifth carbon, and this one is first carbon. So this first carbon, carbonyl carbon, forms hemiacetal linkage or forms hemiacetal with fifth carbon, and it forms cyclic structure of D-glucose. And when this D-glucose cyclic structure is formed, it has now this first carbon is converted into asymmetric center. Previously it was C double bond O H, like this aldehyde, and this is not asymmetric center, but now there are four different groups attached to four sides. So this will become asymmetric center, and it gives rise to two isomers, and so we get alpha D plus glucose and beta D plus glucose. So alpha D plus glucose is the molecule which has OH on the right hand side, whereas beta D plus glucose has OH on the left hand side. So the important consequence of the formation of this cyclic hemiacetal is generation of new chiral center at C1. The structure of alpha D plus glucose and beta D plus glucose differ in the configuration at C1 only. Only there is difference between the configuration at C1. The isomer having OH at right side, termed as alpha D plus glucose, and the isomer which has OH at left side is termed as beta D plus glucose. In aqueous solution, these hemiacetal undergo interconversion via open chain structure to attain equilibrium, and this is known as mutarotation. These alpha and beta hemiacetal on treatment with methanol and hydrochloric acid forms methyl alpha D glucoside and methyl alpha beta D glucoside. So if it is on left side, this is methyl beta D plus glucoside, and if it is on the right hand side, then it is methyl alpha D plus glucoside. These two methyl glucosides are anomers of each other, and these are actually isolated, and their physical properties and uh, all other properties are different. These are optically active. They do not give any reaction. These are optically active. They do not give they do not give any reaction of free CHO group. They do not spontaneously revert to aldehyde and alcohol in aqueous condition. These glucosides do not undergo mutarotation and do not reduce Tollens or Fehling's reagent. To explain these facts, Tolan, Fischer, and Tornade in 1926 proposed the structure that is D plus glucose as a cyclic structure. So D plus glucose has cyclic structure represented as this one, alpha D plus glucose, and this is beta D plus glucose. Let us observe these two structures keenly. What is the structure of alpha D plus glucose? This six-membered ring is there. H, OH, H, OH, H, OH, OH, H. This is oxygen. And here H, CH2OH. This is the structure of alpha D plus glucose. And this is structure of beta D plus glucose. What is the difference? Difference is only at this center, and where OH is towards right when we draw Fischer projection, and it is at the bottom or downward direction when we draw cyclic structure as like this. And in case of beta D plus glucose, the OH is on the upper side, and here it is on the left hand side, that of C1. So D plus glucose is the hemiacetal corresponding to reaction between aldehyde group and the C5 hydroxyl group of the open chain structure. It has cyclic structure because CHO and OH groups are a part of same molecule. As hemiacetals are readily hydrolyzed by water in aqueous solution, either anomers, that is alpha D plus glucose and beta D plus glucose, is converted via the open chain form into equilibrium mixture containing both cyclic isomers. This phenomena, that is mutarotation, result from the ready opening and closing of the hemiacetal ring. The typical reaction of D plus glucose with phenylhydrazone, oxazone formation, reduction of Tollens and Fehling's reagent are due to the small amount of open chain compound. So all these reactions are shown because of some little amount of open chain structure. Thus, the cyclic structure, that is D plus glucose, is confirmed, but whether it is five membered, that is furanose, or six membered pyranose, it is not confirmed. So, in the next lecture, we will see what is the size of ring of the structure of this cyclic structure. Thank you.